Live, and I'm live. Yes. This has been what feels like a very long couple of weeks. It really, really has. It's just, I don't even know. What is this? Oh, sweet. He sent me his code. Sorry. I was just trying to look. I'm still in last class period mode. If you're interested in cryptology, you can take it next year. It's the general idea of, it's not just code breaking, but it's also code making. So? Oh, goodness. Let's get this thing moving. What I'm doing right now, for those of you in the live chat, I do apologize for getting the code up there later. Got a little delayed. What we are doing first thing first is a quizzes. It's the first thing that I want to do. Now, there are certain instructions that I have for you in regards to this quizzes that I would like you to get done. I'm typing the code currently into the live chat so that people can see what that code is. I want you to join said quizzes. But we will get that thing done. Here's the general idea behind cryptology, just because it's on my mind right now, just because you're asking about, if we're going to learn the thing. Anyway, it's like, do you like puzzles? Like, what kind of puzzles do you like? Jigsaw puzzles? Puzzles, word puzzles, like brain teasers? Cryptology is nothing more than just puzzle solving. There's this one lady who is like her job, like she's a professor of cryptology at some college. And when her kids are like, what do you want for Christmas? She's like, listen, here's what you do for Christmas. Get me 3 separate 1,000-piece jigsaw puzzles. Mix all the pieces together and then give that to me. And that's what she likes to do, because she likes the idea of things eventually becoming clear and light being shined on a mystery. For example, there is this mystery involving the Beale cipher, in which there was this pamphlet that was printed in the late 1800s with 3 numeric codes written on it, in which this guy was basically like, listen, here's the story. I was given these codes decades ago. I've only been able to break one of them, which describes what the treasure is. The first one describes who the treasure should go to in the event that the original owner can't make it. And the third one describes where it is. For 200 years, people have not been able to crack it. They know what the second letter says. They don't know what the first and the third one says. Just like little things like that. Just I love those kinds of mysteries. Anywho, again, for those of you joining, I only got 7 joined in so far. What do we got here? We got at least 9 people in the class. Join up with this quizzes. Get yourself logged in. What's going to happen with this quizzes is you're going to have 10 questions. And I want you to take your time. I want you to take your time. Some of these questions you might be able to figure out in the matter of moments. Good for you. Some of these questions might take you a few minutes. What I am going to suggest to all of you, and some of you have already done this, have some scratch paper. Have some scratch paper ready to go. Because you're probably going to want to do that. Those of you in the chat, thank you for indicating that you are here. Oh, your bus didn't show up. That's silly. But the code, I did post the code right there in the chat. It is 167519. For you to join, please make sure that you are joining said quizzes. This is a practice quizzes, although I will be assigning you a real one early next week. One that will count. But this one for now is just practice. My intent is to go over some of the more tougher questions when we are done, and then to expand upon our notes a little bit with some information that I got for you. and we'll see how this goes. But seriously, this 2 weeks. Has anyone else felt that these past 2 weeks have gone by at a snail's pace? Right? Really? Because it's like midterms and then 2 fake snow days. Like my daughter spilling her smoothie. Like it's just been one thing after the other. Oh, goodness. Here, I'll show you one more visual example of cryptology. You ready for this? Cryptology is nothing more than, okay, how do I crack this code? How do I make this code? I need an algorithm for doing it, and I need a key that unlocks it. So you can see this right here. You see this? Rubik's Cube.
Oh,
Nothing crazy about this Rubik's Cube, right? Oh, what were you going to say? Maddie Green, yeah.
Yeah, she has a Rubik's Cube and she wants, when she comes back to school, she's going to bring it to you so you can solve it for her.
Okay. But check this out. Now, this may seem unassuming. The algorithm for solving a Rubik's Cube.
I heard that like you have to keep going like till the right.
Nope, not at all.
It's like a pattern to keep doing the same thing.
Nope. You know why? A pattern on the Rubik's Cube. If you were to repeat what you were saying, I know exactly what you're saying. That's a fake video, by the way, that you watched.
Wow.
Yeah. But the pattern that they're referring to will only cycle through 128 iterations. 128 iterations of the Rubik's Cube. That's what it will cycle through. Do you know how many ways you can scramble a Rubik's Cube? 43 quintillion. Yeah, quintillion.
I don't think that's true.
Yeah, it is.
That just doesn't feel real.
So if you're doing like the thing, I've seen it. It's a joke. Yeah, believe me, I've competed in national championships for Rubik's Cubes. I know what I'm talking about. My whole point of cryptology is once you apply the algorithm and you get to the key, which is the key is like what it looks like now, then the mystery can be revealed. This thing doesn't open unless it's solved. And then I can hide something on the inside.
Really? I didn't know that because I never solved one.
This is not a real Rubik's Cube. Real Rubik's Cubes don't do this.
Oh.
Yeah, real Rubik's Cubes don't do this. I don't know. I have speed cubes at home, but I don't like to bring them in now. But anyway, let's get started. Like I said, scratch work. Take your time. Take your time. I'm gonna click start. There it is. Probably. I don't know if anybody falls into that category. give you guys another minute or so to wrap this up before we begin going through certain problems. All right. Click, click. Okay. My apologies to those. There were a couple who hadn't finished, but I wanted to make sure we moved along with this because there are certain problems that I would like to go through. So here's what I need from all of you. I'm going to need those Chromebooks closed up and put away, and I'm going to need those notebooks out and open. Let's do it. We got stuffs to do. And there are at least a couple of problems in red. Now, some of these problems, obviously, you guys pretty much nailed. You knew exactly what it was that you were supposed to do. But there were other problems that are in red that I would like to go over with you. Let's see. I'm going to flip my camera over in a moment after I write out the problem that I need to do. Right now, I am calling this Quizzes Review Radicals. Today is the 5th. And the first problem that I am writing down, you will see in a moment once I get the camera flipped over to here. Oh, come on, you. There you are. There's my first problem that I want you to copy down. The third root of 64 m cubed. This is directly from the quizzes itself. I need a new one of these markers. Cha-cha! Nobody finds that impressive anymore. Fine. I'll do it with a brick. Anyway, the third root of 64 m cubed. Now, 64, I know what 64 is in terms of a perfect square. I know that 64 is a perfect square, but that does not help me here. Knowing that 64 is a perfect square is meaningless because it is a cube root. So I can't break it up 8 times 8. I'm sorry. So you could do one of two things. You could either attempt to break up 64, as we've done in the past, by dividing it by 2 until you can't go any farther, or whatever number you end up dividing it by, which in this case, it would be 2 to the 6th power. Or you could recognize one of your perfect cubes. The fact that 4 times 4 times 4 is 64, or 4 to the 3rd power is 64. Recognizing that about the number 64 is incredibly helpful, because now I can actually break the problem up like this. I am allowed to break the problem up in such a way because of multiplication or division being on the inside of that problem. And as a result, and I'll write this in red so you can kind of see it a little bit better, but this 3rd power and this 3rd root, which also includes the radical, cancel each other out, leaving you with just the 4m. Now, I'm going to check the quizzes in a minute because I want to see what you guys picked for that, because it seemed like that particular question was in the red for today. Well, let's just see it. Click. Nope, not that one. There we go. Looks, oh, wow, it looks evenly split across the board. It looks like it was just I don't know if it was random guessing or not. 7 people did pick the 8. So again, that's not a square root. That is a cube root, and we have to recognize that cube root as such. Okay. Let me see, number 4. Oh, heck yes, number 4. Let me write down number 4, and I'm going to flip my camera back. Third root of 297, w to the 6th, g to the 6th. There we go. There's the next problem. Now again, something I want to point out. 297. I don't know what the heck to do with 297. I don't know what 297 is made up of. I don't have to know off the top of my head. I can have the calculator do it for me. So if I go to the calculator with 297, clearly I can't divide it by 2. Can I divide that by 3? I think I can. Oh, sweet. I think I can do it again. And again. Oh, I can't do it anymore. I was able to do it 3 times. So 3 to the 3rd power. Hold on. Get out of there, you. Times 11, 297. Heck yeah. That'll be helpful. Let's break this thing apart. Now, not only am I going to break this thing apart, but I'm also going to break apart the w and the g. This is the 3rd root of 3 cubed. Let's zoom in on that. Times 11. That's the 297. The w to the 6th could be broken up like this. And the g to the 6th could be broken up like this. Now, as a result, again, this being a cube root, the only thing that is allowed to escape a cube root is if it has the proper exponent. Now, what I've just done is I put parentheses around everything that is allowed to escape. The 11 does not have the proper exponent to be able to get out of the problem. Ultimately, this 3 was able to get out. A couple w's, actually 2 w's were able to get out, but it's w times w, w squared. Same thing with the g's, g squared. And what's left over, unable to escape the problem, is that cubed root of 11. Again, let me zoom in a little bit more on that. With these problems, we have to be very deliberate with them. We have to be very deliberate with them. You have to be able to show me a certain progression of information in order to handle this problem. Now, I want us to actually see what quizzes did, like who chose what for quizzes on this one. Let's see. Yes. Okay, hold on. Bring your attention to the board. Bring your attention to the board. I want to show y'all something here. I want to circle this. This was clearly the answer. This was not. But I want to emphasize which one was not. The answer that was not was written like this. That's how the wrong answer was written. Now, I want to emphasize something with you right here. Why is that answer wrong? Why is that answer, the 4th option, why is that one wrong? It has the 3, it has the w squared, it has the g squared, it has the 11. What's wrong with it? Because Three of you chose that. What's wrong with it? Why is that last option wrong? More specifically, the little cube root. Yeah, it's missing that. If that little 3 is not there, what type of root do you assume it is? Yeah. If that little number is not there, you assume it's a square root, which is not what this thing was. There you. Yeah, she said it in the chat too. I just didn't see it in time. We have to be careful with that kind of thing. You always have to pay attention. The roots don't change as easily as just, I just want to change it. No, they don't just change for the sake of changing. There has to be a reason and a rationale behind it. But that's why that last option was wrong. It has to be that little cube root thing right there with that little 3. I moved it. There it is. Okay. Back to the quizzes. Those were the 2 that were in red. Let's take a look at this one. This is a good one. Okay. Let me write this one down, and then I have a few questions. This is the cubed root of 135 p to the 4th. There we go. Zooming out. There we go. There's the problem. Question. How do you know if a number is divisible by 2? Really? Yeah? Yeah, it's if it's even. How do you know if a number is divisible by 5? Where? Okay. How do you know if a number is divisible by 3? Yeah.
You add the numbers up and make it divisible by 3.
1 plus 3 plus 5. It adds up to what, 9? It's divisible by 3. There's a rule for every single digit number except for 7. The rule for 4 is you look at the last 2 digits. If the last 2 digits are divisible by 4, then the whole thing is. The rule for 6 is basically the rules for 2 and 3 together. The rule for 8 is you look at the last 3 digits. And if the last 3 digits are divisible by 8, then the whole thing is. The rule for 9 is you add up all the digits similar to 3, but it has to be divisible by 9. 10 is easy. It just has to end in a 0. Did I teach you the rule for 11? 11's ridiculous. Give me a number that's divisible by 11. I'm sorry. Give me a number that's more than 2 digits. 121. There we go. 121 is divisible by 11. Check this out. Plus 1 minus 2 plus 1. What's that equal? Plus 1 minus 2 plus 1. What do you get? You get 0. If the result is divisible by 11, then the whole number is divisible by 11. It's really sick. Check this out. I can do it with this number. I can do like, I don't know, 3, 0, 4, 1, 5. Yeah, that'll work. That number is divisible by 11. It is. Guaranteed. I can prove it to you. Go to my calculator. It's really messed up. 30415 divided by 11. Boom, works perfectly. Because I could take plus 3 minus 0. You basically alternate. Plus 3 minus 0 plus 4 minus 1 plus 5. The result is 11. And since 11 is divisible by 11, that number is divisible by 11. It's crazy. Math is weird. It's almost like the rules exist outside of time and space. Back to this. The reason why I bring up that for 135 is because I just wanted to figure out very quickly, is 135 divisible by 3? Well, yes, it is, because you could add up all the digits and you're good. 135 is clearly divisible by 5. So let's go with 135 divided by 3, divided by 3, divided by 3, and there's the 5. Sweet. It doesn't take that long to figure out what to do with 135. In fact, you could have done it the other way. You could have divided it by 5 first, and then gotten the 333 from the 27. There's people in my hallway. Why? Anyway, back to this. So if I'm going to break that thing down, this would be the third root of 3 cubed, 5 to the first, and hold up. What the heck do I do with that p? Question. When I say p to the 4th, what exactly is happening to that p? If I say p to the 4th power, what operation is taking place? What does the 4th power tell us to do? Multiply what? But I don't have a number here. Say again? Well, it's p to the 4th. Yes, it would be p times p times p times p. I was also secretly, immaturely hoping that someone would just go p, 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 p. It would have been hilarious, and I would have high-fived, but it didn't happen. Did you put... Anyway. But yes, it is p times p times p times p, but it's a cube root, so I'm going to break it up like this. Because I need to have the proper exponent to get something out of there, to simplify it out of the problem. This 3 can escape. This p can escape. They're allowed to escape. That 3 and p are on the outside now. Good for them. What's left on the inside are the terms that were not allowed to escape the problem. That's what this thing does. This is the practice that we have to get. I want to do one more. I want to do one more from the actual quizzes, and then I have some extra notes to kind of remind you of as we go along here. Oh, you did? That was okay. Yeah, that one was okay, I guess. Hold on 1 second. Okay, good. I was hoping that nobody picked I give up. I would have been very sad if they picked I give up. That would have. Anyway, let's do this one. Clearly the answer is already there, but let me write this one down. This is the square root of 108 d to the 5th g to the 3rd. Anybody watch Lost back in the day? Yeah? Do you know the numbers from Lost? All right. The only reason I bring that up, not only am I obsessed with just the show and numbers and all that stuff, but if you take the numbers from Lost and add them all up, you get 108. Those are the numbers from Lost. Just saying, it's a decent show, except for the ending. Don't watch the ending.
Yeah, it was really bad.
It was. Anyway, back to this.
There's like a lot of seasons too, and they ended it like that.
Well, the thing was, after season 3, no, actually, in the middle of season 3, they negotiated to end it after 6 seasons. Yes, the producers did. But here's a secret that you don't know about the show. The show was originally created by J.J. Abrams and Damon Lindelof, right? They had a meeting to discuss the show. And over the course of that meeting, several hours, they fleshed out the entire first season. And by the end of the meeting, they were like, well, how are we going to answer all these questions? And one of them's like, well, the show's not going to get picked up anyway, so who cares? And then the show got picked up, and they're like, oh, crap, we actually have to write this thing? So J.J. Abrams is like, see ya, I'm going to go do Star Trek and Star Wars. And Damon Lindelof was stuck doing Lost. Yeah. True story.
It was just like a weird ending. It didn't make any sense.
Well, the theory when watching the show the first time, because you guys were all like, how old were you in 2004? Yeah. When the show first came out, it was insane because people were like, what is this? What is this? What's going on? What's going on? Everybody assumed it was like purgatory. It's like, no, it's not purgatory. It's not purgatory. And then in the last episode, they're like, JK, it was purgatory. Like, that's a dumb ending. Anyway, back to this. Let's take the number 108 and let's break this number apart using division. Divide by 2, divide by 2. I can't go any farther, but there's our 27. That's a 3, a 3, and a 3. Good. Which means that this number is actually the square root of 2 squared times 3 cubed. If you wanted to actually write it out, 2 times 2 and 3 times 3 times 3, that's fine. Oh, but you know what? What type of root do we have? What type of root is on this problem? So, the only thing that can escape a square root is a perfect square. I can't write the 3 like that. Instead, I'm going to cross this 3 out, and I'm going to write it as 3 squared times 3 to the first, because it's a square root. Now I want to deal with that d. D to the 5th. The d to the 5th, again, just to emphasize, is d, there's my hand, d times d times d times d times d. There's 5 of them. But it's a square root, which means I can have a d squared, and a d to the first. Same thing with that g, a g squared and a g to the first. I'm breaking them up so that I can get the appropriate exponent that is allowed to escape the root. You have to know what type of root you have. This 2 is escaping. This 3 is escaping. These d's are escaping. And this g is escaping. Nothing else. So 2, 3, multiply to get you 6. D and D get you a d squared and a g. Those are the terms that escape. And what is left over are the terms that I did not indicate would escape. 3, D, G. This would be the appropriate answer. Just breaking it down piece by piece. What do I do with the 108? Break it down, divide it. Do what you have to do to divide that thing out. The variables, break them apart. Again, in the appropriate fashion. Okay. I'm going to be showing you something slightly different today with the remaining time that we have, but I do have to show you this stuff because the stuff is very illogical. It is very, it progresses nicely from what we've just done. It reiterates some of the previous information that we've touched upon, but it does take it in a slightly new direction. So let's see. Let's see. Hold up now. Hold up now, paper. There's my paper. I'll put the paper over here, and I put this paper over here. And I want to remind you of something that we've learned in the past. I need to reiterate this point right here. And the point that I'm trying to reiterate is this. We've written that down before. I want you to write it down again. That definition, that relationship is vital towards understanding how to do the rest of this chapter. Recognizing that when you have a root of some kind and a power of some kind, you can rewrite that problem as a fractional exponent. Or vice versa, if you have a fractional exponent, you can write it as this radical. The way that I taught you to remember and the way that I try to remember is when you have a fractional exponent, you must try to remember the phrase power over root. M is the power, N is the root. Here's an example. I might give you an example to evaluate 8 to the 5/3 power. And it may be very easy to say, well, I'm just going to type this thing into my calculator. Unfortunately, as you know, there are problems that require you to explain, to show why this works, to show a logical progression of work in order to prove that the answer is what it is. You cannot just say, calculator. By the way, let's just see what it is in the calculator. 8 to the 5/3 power is equal to 32. What the heck? 32? 8 times what will get you 32? Yeah, but unfortunately, I don't see how the 4 comes into play. Like, what the heck? Here's what happens. Here is what you should be logically thinking. I'm going to convert this into what we call radical form. That is the appropriate radical form that you can convert this thing into. Notice something very important here. First of all, the fractional exponent is 5/3. Power over root. It is a third root. Thus, I put a third root on the problem. The second thing that you should notice is the fact that I put that power of 5 on the outside, even though I had it on the inside over here. Well, that's okay. Technically, this power could be on the inside or on the outside. It's kind of commutative right there, or associative, I should say. It could be on the inside or the outside. Question or stretching? Cube root of 8. This is what you should know. Or we could confirm this in the calculator, which we will in a moment. Do you guys know the cube root of 8 off the top of your heads? A number when multiplied by itself 3 times will give you 8. Yeah, it's just 2. Hold up. Hold up. There we go. This equals 2. Oh, but it's also to the 5th power. You know 2 to the 5th power off the top of your heads?
32.
Yeah. You should memorize those powers of 2. If I asked you any power of 2, would you be able to get it? Within reason?
Yeah.
Like, what's 2 to the 10th power?
No.
1024. Here's what I've done. I've memorized only 2 to the 5th and 2 to the 10th. That's all that I've memorized. Because if I can memorize just those 2, I can just think about getting the next in between and above. For example, if I know that 2 to the 5th is 32 and somebody asks me 2 to the 7th, all I have to do is think, okay, 32 times 2 times 2, 64, 128. All I'd have to do is memorize a couple of them and I can fill in the gaps. Okay, nobody cares. I also love tournaments back in the day. Tournaments have to have a power of 2 participants in order for it to be fair. So, anybody watch tennis tournaments? Am I the only one?
Probably.
Okay. Was I the only one when I was like 6 years old to watch the U.S. Open on USA and actually like sketch out the bracket? All right. I love tournaments. I love writing out tournament brackets. Just, it's fun. Shut up. Anyway, back to this. Example. What? Of what? To the death? I said that, and you know I said it jokingly, but when I said that, you immediately started thinking to yourself, I could probably take out like half the people in this room.
I'll start. Ooh, no, that's after it. Please don't send me to the office.
You start with the biggest threat in the room. I see how it is.
I'll be bumped. The biggest threat. Here's the biggest threat.
You just got to get him when he's not paying attention.
Yeah. He's never paying attention.
The biggest threat is not always the strongest person.
Yeah, oh, I know.
Yeah. Anyway. So you know what not that I've thought about this, but if there ever was like a fight to the death that broke out in the middle of one of my classes, my immediate reaction would be to get out the door and barricade it and just let y'all fight it out. Anyway, back to this. I'm not getting in the middle of that. That's the smart thing to do. Hey, negative 256 to the 3/4 power. Oh, 256? How the heck am I supposed to figure this junk out? You can have the calculator do some of the stuff for you. You can, some of the stuff. Not all of it, but some of it. Here's what you can do. First, I'm going to convert this thing to be in radical form, but watch how I convert this thing. Notice, where did I put the negative? Yeah, on the outside. Now, this is important. This is important because, watch, I'm going to write this thing on the board. It's going to be, if you put that thing on the inside, it changes the complexity of the problem. If you put that negative on the inside, it changes the complexity of the problem. Technically, you are not allowed to take a fourth root of a negative. That would get you a complex answer. The reason why that negative is on the outside of this problem is because there are no parentheses on the original problem. Actually, no, I'll do it like this. If there were parentheses like this, then yes, that negative would be on the inside of that radical, because that negative would also be affected by the exponent. But because there are no parentheses, you have to assume that that exponent is only affecting the 256. Let me show you my calculator real quick. Check this out. You tell me, what is negative 3 squared? What is negative 3 squared? People would say 9. Watch this. Look what I just typed. Why does that happen? Parentheses, negative 3, parentheses, squared. Now it's positive 9. Parentheses make all the difference in the world. You need to be aware of that fact. So for this problem, there were no parentheses in the original problem, which means that that negative sign is on the outside of the radical. The fourth root of 256. Oh, man. Mr. Markey, how are we supposed to figure out the fourth root of 256? I don't know. Check this out. 2 to the 4th power, 3 to the 4th power, 4 to the 4th power. Hey, look, I figured it out. How long did that take me? Yeah. I'm not expecting you to figure out 256 off the top of your head or the 4th root of 256. But you can have the calculator do a lot of the stuff for you. So this really should be negative parentheses 4 parentheses to the 3rd power. Which, 4 cubed. Again, you could do the calculator. Answer is negative 64. Answer me this. What did that negative do for the entire problem? What did that negative sign do for the entire duration of the problem? It's actually an easy answer. Say again? That negative just basically did nothing. It just chilled the entire time. It's like, I guess I got nothing to do. Here I am again. Not even involved. Oh, we're done. It did nothing. It just hung out the rest of the way. It's a crazy problem. Okay, one more, and then I'm done for today. I am so hyped on a Friday afternoon. I know it's not even afternoon though. Can you imagine if we had the school day till 1:50? Okay, imagine we had the school day till 1:50, and this is period. Well, let's just pretend it's 4th period. My energy level at 1:30 is pretty much the same as I am right now. I just made a coffee. Guess how much I've drinking of it? Nothing. I haven't had any coffee today whatsoever. I've had a bowl of Cocoa Pebbles. That's it.
How long do you sleep
I don't know, like 3 hours.
for? Oh my God.
No, average probably a 5. I actually do have proof of that, but that's another story. Because I have a Fitbit. Fitbit keeps track of it. So yeah, I probably get about 5 hours. Why?
Apparently your brain, like, if it's under 8 hours, it doesn't, like, hit the maximum, like, sleep. It's basically the same as running on the
Eh,
and, like, that's kind of crazy.
I got 2 kids under the age of 7. I'm used to it. 64 to the 2/3 power over 343 to the 2/3 power. Oh my goodness. What the heck am I supposed to do with this problem? 64 I recognize, 243 I don't. What the heck? 343, whatever. Look at the exponents. Look at the exponents. They're both the same, obviously, but what's the root on both of those exponents? What type of root is on this problem? Remember, the fractional exponent is a phrase, something over something. What's the root on both of those numbers? Yeah, it's a 3rd root. So hold up a sec. 3rd root. Let me go to my calculator. 3rd root of 64 does work. I have no idea what the heck is 343. 3rd root of 343. Holy crap, it's 7. I didn't know that. You don't have to know that, but the calculator can help you move along with this problem because this is what I'm going to do to the problem. First, I am allowed to do the following. And the reason why I am allowed to do the following is because of the multiplication division that is within the problem. Then I can take the 3rd root of all of that stuff. I just did the 3rd root in the calculator for both of them. It's a 4 and a 7. And then ultimately, I just have to square it. 16 over 49. I do apologize for rushing this problem as we are out of time. So, as I've said, I will be assigning you guys something early next week that will count. I'm going to leave this up here temporarily, just in case people need to copy that thing down, because the bell has now rung. But if you have a copy down and you need to skedaddle, then please, by all means, I'll see you next week. See ya, you too. Oh, my glasses. You too. Sorry, that was a bad timing. Thank you, you too. Bye-bye. All right, I'm going to sign off. You too. See you guys.